So when we talk about confidence intervals and hypothesis testing, they are related, right? They both leverage the fact that our p-hat, our sample proportion, follows an approximate normal centered at the real proportion, the true proportion. So they both use that normal distribution. There's a z related with both, right? In confidence intervals, we have our critical value based on that middle probability, right? So we got this, and we get our z. In our hypothesis test, we go ahead and we get a z, and then we look at, and especially in a two-sided hypothesis test, we look at the tail area. So we can kind of see how these two things are kind of complementary to one another. So there's two things that we discovered when we did our worksheet in class on Thursday. One is if our p-naught is outside our confidence interval, in the related test, we would reject the null. And we actually saw this and saw exactly why it made sense, right? It was kind of common sense. And you're like, oh, well, if I think the value is between 0.4 and 0.6, then it can't be 0.7. And if our p-naught was inside our confidence interval, within our range of values, we could not reject it, so we failed to reject the null. So those are the two things that we discovered in the worksheet. There is one piece here that we didn't get out of the worksheet, which is how our confidence level is related to our alpha level. And that is entirely based on these little pictures I drew, right? This is our confidence level, the middle percent, and our alpha is the acceptable amount of tail probability, right? Especially in a two-tailed test. So if we're thinking about confidence intervals on this side, our confidence level and our significance level are complements of one another. So if we had, say, a 95% confidence level, that's the same thing in a confidence interval as having a significance level of 0.05 in the two-tailed test only, because in that case, we're doing those opposite two tails. So we can kind of go back and forth. So now we have two quick examples where we basically run through a confidence interval again and see how that would compare to the hypothesis test, and we run through a hypothesis test again, and we see how that would compare to a confidence interval. So these you can just do on your own if you want, or you can continue watching. But at this point, this was the one thing I hadn't told you yet. The rest of this is us doing the same work we've already done a bunch on worksheets. So anyways, I will continue on. 19%, according to the Society of HR Management, 19% of HR professionals are concerned with losing their jobs. Suppose in a recent sample of 1,000 employees that 200 say that their biggest concern is losing their job. So this looks like it might end up being something to test. It's not necessarily the real thing, right? It's according to the Society of HR Management, so we can't call it a P, but it's not from a sample that we're aware of, and we don't have a sample size for it, so it's probably our hypothesized value. Then it says, let's go ahead and calculate our confidence interval. All right, we can do this, especially we could go to the formula sheet and grab the formula, p hat plus or minus. Those of you with the smaller calculators, the 36x, you've probably gotten very good at this. I'll go ahead and just type in what I would have if I were doing this. I think it's 1.96, my God. I don't know why I'm being slow. And then 0.2, 0.8, and 1,000. But if we have the graphing calculator, we're able to just go ahead and use the calculator shortcut. So we'll go, I always want to press second, stat, and over to tests, to one prop, pass z test, remember, because we're doing an interval now, to z interval. And we'll just put in our x, our n, and then our corresponding confidence level. So we are at 0.1752 to 0.2248. 0.1752 to 0.2248. So there's our confidence interval. Done. Now, part 2 says, let's use that duality bet. Without conducting a hypothesis test, do you think there's evidence that the proportion of current employees who are concerned about their losing their job is different than our hypothesized value? So basically, we're looking at these two hypotheses. Our null is that it is equal to 0.19, that the Society of HR Management was correct. And our alternative is that we just want to say, nah, it's something different than that. And we can look and we see 0.19 falls right inside that interval. It's pretty dang close to our 0.2 that was our p hat. So, no. Whoa, that is not what no is. No, because we are 95% confident that the proportion is between, I'm lazy right now, I don't have a lot of space, so I don't want to write out, is who are concerned with losing their job is different. It's between 0.1752 and 0.22548. So it could be 0.19, right? And if you really wanted to make this a lot more concise, you could just think here, we're talking about inside equals fail to, whoa, my hands are not connected to my brain, fail to reject the null. So since that's there, we cannot say that it's not equal to 19. It could be equal to 19, so we have to fail to reject it, and that's still a possibility. I'll pause the video now and then do the second exercise separately, so that way this is a little shorter.